Hi everyone, in this video I'm going to talk about the Hyatt Regency Walkway collapse case in a point of view of the engineering ethics. This video will be content with background, chronology, case analysis, ethical analysis, suggested solution, aftermath, and references. Let's start with the background. So on July 17, 1981, during a weekly dance held at the Hyatt Regency Hotel, Kansas City, the connection supporting the middle section of the fourth floor walkway failed, causing it and the second floor walkway it supported to collapse onto the crowded atrium floor. Totally, 111 people died immediately. 3 people died later in the hospital, and 216 people were injured. It was the most devastating structural collapse in United States history. In response, the client immediately sought an expert to investigate the circumstances leading to the failure. Let us see the chronology before this incident happened. So in 1976, Crown Center Redevelopment Corporation commences project to design and build a Hyatt Regency Hotel in Kansas City. Guillaume Colaco Incorporation selected as the consulting structural engineer for the Hyatt project. In 1977, GCE assisted owner and architect with developing various plans for hotel project and decided on basic design. And then late on 1977, BID set up structural drawings and specification. In 1978, the project prepared using standard Kansas City, Missouri building codes, and in spring 1978, construction on hotel begins. In 1979, Heavens, which is the name of the fabricators, makes design change from a single to a double hanger road box beam connection for use at the fourth floor walkways. GCE received 42 shop drawings and returned them to Heaven stamped with engineering review stamp approval on February 26. Part of the atrium roof collapsed while the hotel is under construction, but the owner seems to ignore it and still continue the construction. In 1980, construction of hotel complete and the Kansas City Hyatt Regency Hotel opened for business. In 1981, connections supporting the roads from the ceiling that held up the second and the fourth floor walkways across the atrium of the Hyatt Regency Hotel collapsed. Why did the walkways collapse? So after doing some readings, we find three main reasons that caused these walkways collapse. The first one is the original design change, and then the negligence of the owner, and the last one is the structural design of the walkway was inadequate. The main attraction in the hotel lobby was an atrium spanned by 3 pedestrian walkways at the second, third, and fourth floors suspended from the roof. As we can see that here is the appearance of the atrium in where the walkways were located. So we can see from this picture that the second and the fourth floor walkways are suspended above and below each other, and then the third floor walkways were located independently suspended offset. Each bridge was roughly 12 feet long and weighed 64,000 pounds, and was suspended by 3 pairs of hangers at the end and at uniform intervals. So the original design by Jack D. Gillum and Associates called for 3 pairs of rods running from the second floor all the way to the ceiling. But then the Heavens Steel Company, which is the fabricator in this project, disputed the original design because it made assembly more complicated by requiring the nuts to be threaded the entire length of the rod. The contractor proposed an alternate plan where 2 separate sets to the tie rods would be used, one connecting to the fourth floor walkways to the ceiling and the other connecting the second floor walkway to the fourth floor walkway, and submitted shop drawings. It was determined that the load on the bolt at the fourth floor would double with this design. As we can see in the original design, the nut that supported the fourth floor walkways only required to support the weight of the fourth floor, but after the modification of the design, the nut that supported the fourth floor have to carry also the second floor walkways. So now the road connecting and the fourth floor to the roof has a double load but the same strength. This caused the walkways to collapse. But how can this passing the inspection and who are responsible to check all the calculation? Because there is a miscommunication between the engineering firm and the contractor. Drawings submitted by Jack P. Gillum and Associated were interpreted as the finalized drawing, even though they were preliminary sketches. Because of an immense lack of communication between the engineering firm and the contractor, the changes proposed by the contractor were made and accepted without real calculations being performed by the engineering firm. In court, the contractor claimed he called and received approval for change. However, the engineering firm denied that the call took place. But interestingly, 10 days after 42 shop drawings were submitted for approval, they were stamped and approved for construction. The second reason is because of the negligence of the owner. On October 14, 1979, while the hotel was still under construction, more than 2,700 square feet of the atrium roof collapsed because on one of the roof connection at the north end and the atrium failed. And then the GCE stated that on 3 separate occasions, they requested on-site project representation to check all fabrication during the construction phase. However, the requests were not acted on by the owner because there is an additional cost of providing on-site inspection. So regardless of the design that had been changed, the original structural design of the walkway also was inadequate. We can see that the ultimate capacity of the box beam hanger road connection still would have been far short of that expected of a connection designed in accordance with the Kansas City Building Code, which is based on the AISC specification. In terms of ultimate load capacity of the connection, the minimum value should have been 1.67 times 20.3 or 33.9 kips. But then, based on the test result, the mean ultimate capacity of a single road connection is approximately 20.5 kips or 91 kilonewton, depending on the weld area. Thus, the ultimate capacity actually available using the original connection detail would have been approximately 60% of that expected of a connection design in accordance with AISC specification. In order to help us to do the ethical analysis, I provide some information about the Code of Ethics of Engineers that being used in United States at that time. So the first one is ASME, Code of Ethics of Engineers. This ASME consists of two parts. The first one is the fundamental principles and the other one is the fundamental canons. You can pause the video to read it. Another one is the IEEE Code of Ethics. So after getting ourselves being quite familiar with the codes of ethics of engineering in United States, we can do the ethical analysis. So who is ultimately responsible for checking the safety of the final design? So at that time, there was no regulation that specifically stated which party is ultimately responsible. But even so, both of the engineering firm and the fabricator have violated some code of ethics, such as the first one, the ASME Code of Ethics of Engineering's point 1, which say using their knowledge and skill for the enhancement of human welfare. They also have violated the fundamental canons which say engineers shall hold paramount of safety, health and welfare of the public in the performance of their professional duties. And also the IAEA Code of Ethics which say to accept responsibility in making engineering decisions consistent with the safety, health and welfare of the public, and to disclose promptly factors that might endanger the public or the environment. For a solution, I come up with two ideas, which is the first one is to determine a party responsible for finalized design, because the main problem in this incident was neither the designers nor the builders assumed responsibility for the final product. This is not a matter of placing blame on one group or another, but rather of determining at what point one can consider an engineering project to be finalized. Without clear guidelines and procedures, miscommunications and assumptions could strike again rather easily and putting lives in danger. We suggest a rather simple procedural solution: implement a clear guidelines for determining ultimate responsibility for a design. Another one is to create formal design review process. Even with responsibility for the design established, another element missing from the conception and construction of the lobby was formal oversight. As had shown, part of the reason that unapproved design changes were made is that the design review process was ineffective. So creating a formal design review process is, I think, one of a possible solution. After the incident, the owners of the Hyatt Regency Hotel have to pay over $140 million in damages to the victims. And for Daniel and Jack, they found guilty of gross negligence, misconduct, and unprofessional conduct. And this caused them to lose their engineering licenses in the state of Missouri and Texas, as well as their American Society of Civil Engineers membership. And for GCE, it had to lost its certificate of authority as an engineering firm, but Jack himself continued to take speaking engagements at engineering conferences so that others might learn from his mistakes. And American Society of Civil Engineers changed a code to state that the responsibility of a design lies with the engineer's seal. The engineer that placed the seal of approval upon the said plans carries the responsibility for the building and its outcome. And the Hyatt Regency today, now called as Sheraton Kansas City, renovate numerous times, though the lobby still remains the same layout, and lobby reconstructed one walkway on the second floor only and supported by several columns underneath rather than suspended from the ceiling. Here are some references that I used to finish this report, and thank you.